The City of London, also known as the Square Mile, is the centre of British finance and one of the world's most influential business districts. Almost 500,000 people commute into this compact area every working day. These people and their employers have huge demands for energy, heating, and air conditioning. Few realise that power comes from within a fascinating network of tunnels and chambers underneath the city. Some are centuries old. Others were created during World War II in London's darkest hour.
This huge area was completely flattened, devastated by the Blitz.
But what subterranean structures from our past are shaping our future?
Welcome to the old engine room.
Wow, this space is enormous.
And how can 21st century power be distributed around a complex underground network in a city that never sleeps?
People are totally oblivious to what's beneath their feet.
On the outskirts of London's financial district stands a 19th century building that goes largely unnoticed by passers-by. The street-level facade belies a vast system of underground spaces which house the largest urban combined heat and power system in the UK. At the centre of this warren sits an impressive 4-storey energy station, and John Armstrong is its Director of Operations.
Often, when I tell people where I work in London, they don't believe that there's a power station right in the middle of the city, and it's actually only when they walk past they realise what's here and look in a bit more detail.
So how did a power plant end up in the middle of the centuries-old district of London? The historic Smithfield Meat Market may provide the answer. When the building was redesigned in 1860, it gave rise to a system of underground spaces which have been integral to its growth and expansion over the years. Roger Morgan, an expert in subterranea, has been investigating the legacy of the changing uses underneath these buildings.
We're standing in Smithfields, which is the medieval meat market. Below the main selling floor was a huge railway goods depot where the meat trains from the north would discharge their cargoes and it would be hoisted up onto the selling floor on hydraulic lifts. And then next door is a cold store for storing the meat which wasn't sold immediately.
Meat was stored deep below street level under controlled conditions.
Carcasses, generally cows from the market over the road, were brought in and kept cold in this building. This room is 20 metres long, 10 metres high, 10 metres wide, so 2,000 metres cubed. Potentially you could fit about 8 double-decker buses in here. So this is original steelwork holding up the structure from the cold store from 1895.
In the late 19th century, as electricity and refrigeration developed, coal-powered boilers were installed below the cold storage room. Here they generated much-needed power for the Smithfield market.
In this bolt over here, this bolted structure, which is all brick-lined, you can see some of that history from the original coal power station that was here, and you can actually touch the walls that in 1895 they burnt coal in this space. It's absolutely amazing to think that over 100 years ago, people doing the same job that I do now were here, very, very differently, but generating power and distributing it around the city.
During World War II, the City of London was heavily bombed. The last of Germany's huge rocket-propelled missiles hit Smithfield in March 1945, killing 110 people and injuring dozens more. London's authorities made plans to rebuild the city and especially make use of its underground spaces. Roger is looking at a 1940s map which shows all the plots ideal for redevelopment.
So in orange is the area devastated by the Blitz and the V1s and the V2s. The whole area was completely flattened, which gave the opportunity to the City of London to redevelop the area comprehensively and provide much more service subways to serve the Barbican estate and other buildings. So nearly every modern building since the 60s in the City of London will have a huge extensive basement. So the potential for development for the network in the future is obviously highly significant.
With us for hours. Our time, dating for like-minded singles over 50, sponsors unmissable moments.
The existence of these post-war spaces, some 3 stories deep, proved to be an asset. When the cold store closed its doors as a refrigeration plant in the 1970s, it was to be turned into a more advanced power station using 2 350-ton ship diesel engines. A system was built to supply power, heat and cool water for air conditioning that weaves its way through the subterranean heart of London's financial district. The use of existing spaces saved on digging new tunnels. Kish Barrett manages the subterranean power network.
You wouldn't dream of putting a power station in the middle of the city. However, the use of subways and underground locations where people are totally oblivious to what's beneath their feet is a clever way of delivering local energy. We could only really do this given the access to subways, tunnels and car park locations. Otherwise, we would have to be doing civil excavations in major roads.
More than 6 kilometres of heating pipes and nearly 5 kilometres of cooling pipes deliver vital energy supplies to various residential, business and public buildings.
It allows us to deliver the refrigeration at the Smithfield Meat Market and also for the daily operation of the Guildhall, which is the City of London's corporate centre.
The Citigen underground complex is not open to the public, but Kish has offered Roger a special look behind the scenes.
I'm quite interested in getting into the building, which apparently is extraordinary.
This guided tour fulfills Roger's ambition to see how this historic old power station
So this is where we begin our descent.
has a new use well into the 21st century.
Welcome now to the old engine room.
Ah, thank you. Wow, this space is enormous.
So this is where the old engines were sited, and you can see that the vastness of the room really gives you a feel of how big that equipment was. If you just look up,
Is that soot?
It is. It's the exhaust from that engine process.
Yeah.
In 2016, the 2 diesel engines were removed to make way for 2 brand new low-emission 4.3 megawatt gas-powered engines. The refit cost £26 million. These new efficient engines mean that the Citigen complex can now supply tens of thousands of megawatt hours of heat, electricity and cooled water to more than 11,000 homes and businesses in the City of London. It's all part of London's aspiration to be carbon neutral by 2030.
When we look at the technology now, the higher levels of efficiency, how quiet they run, and also how we use technology and digitalisation, things have come on a long, long way.
This power station is known as a combined cooling, heat and power plant, or CHP. These new gas-powered engines are 80% more efficient than conventional power stations that burn fossil fuels and are lower in pollution emissions. The system has the ability to capture and reuse excess heat at every stage of the energy production process to keep down fuel use. It's all monitored from a central control room by Leke Olowole.
This is Central London's biggest tri-generation facility. Tri-generation is the ability to create heat, chill and electricity from the same source. Up here we optimise the production of heat and chill, which ensures that the CHP is more efficient than a normal gas engine. We store the excess heat in the thermal stores.
The thermal store is like a giant central heating hot water tank.
This is where we generally store our production of heat. It's full of hot water. First time I walked in here, looking up and seeing the sheer size, it hits you how big the energy centre is. The volume of the thermal store is 320 metres cubed. It takes about 2.5 hours to fill it. This is the beginning of the thermal journey where the hot water from the thermal store goes into the pipe and then goes onto the network.
Even as the hot water completes a circuit of the network, it remains at a high temperature. Much less energy is needed to bring it back to the boil than to heat it from cold. The whole tri-power system runs a total of 10 kilometers. Manager Kish is now showing subterranean expert Roger how it flows out through the existing subterranean spaces underneath the financial district.
So Roger, now we're going down to the basement areas of the meat market.
Okay.
We're probably about 250 metres from the power plant.
Okay.
The pipes are running along the length of the underground car park. It's this sort of area or opportunity that we look for to get energy from point A to point B, such that we're not having to do excavations in the road.
Yes, which is an interesting feature of the whole system.
So what we've got here is 4 sets of pipes. 2 sets are the flow and the return of the heating system, and then there's the flow and the return of the chill system.
So the whole thing's a bit like a domestic central heating system, only 200 times bigger.
Absolutely, the flow and return.
Exploring this space, I would never know what these pipes are, so it's fascinating to find out.
One of the beneficiaries of the energy system is the Barbican Estate, built between the 1960s and the 1980s with its mixed use of private homes and a public arts complex. The Citigen pipe network runs right under it.
Here's the run of the pipes coming through the building. And again, this is allowing us to use underground space, not only to serve the energy requirements for the Barbicanet Centre itself, but also take that energy beyond the Barbicanet Centre to other buildings along the network.
The furthest destination on the energy chain is London's Guildhall. Dating back to the 15th century, it was badly bombed during World War II. Reconstruction allowed the addition of new basement levels.
So I'm deep under the Guildhall.
Roger has now reached the final stage of his underground tour.
According to my research, we're 3 stories down, 10 metres, and it's the deepest part of the Guildhall. Where we were standing is the southern fringe of the Blitz bombing. So to the north of us, there was complete devastation. There was just rubble at the end of the war. So there was a huge potential for the whole area and incorporate service subways between all the buildings, which advantages Citigen now is in that they can now lay their pipes through them.
Even though the energy has flowed through a warren of tunnels, it's clear from the monitors how efficient the tri-energy system is, right up to the extremities.
Ah, yes. It's showing the temperatures of the water going in and out. So the in temperature is 93.7 and the out temperature is 71.3. So the water is coming from the hot water store at Citigen, is reduced by 20 degrees and is returned to Citigen, and then they only have to boost it by 20 degrees rather than reheating it from scratch.
As our cities expand and our needs for cleaner, more efficient energy grow, innovators strive to meet London's 2030 target to become a carbon-neutral city.
Isn't it fantastic that these underground worlds are supplying low-carbon power to the City of London's iconic buildings?
What's underground, the subway tunnels, the car parks and basements, allows us to install a network in those locations underground that's benefiting the air quality above ground.
Visit a subterranean city dating back to 800